morning everybody. In this lecture we are going to see some problems on the topic ionic equilibria. The first problem we are going to take on the topic of pH scale. So first problem, calculate the pH and pOH of 0.01 molar HCl solution. So we asked to calculate the pH and pOH of 0.001 molar HCl. Obviously this is an acid and the concentration of H plus is nothing but 0.001 molar. This is what is the concentration we have given, and we have asked to calculate pH and pOH. So simply we can calculate first the pH. We know the formula for pH. pH is equal to minus log of H plus ion concentration. So the minus log of, substituting the concentration 0.001. So this is nothing but minus log of, minus of log of 1 is 0, and here the characteristic is bar 3. This minus minus, this becomes plus, therefore pH of the solution is nothing but 3. Now we want to calculate pOH. Now we know the relation of pH plus pOH is equal to 40. Therefore pOH will be equal to, if you know the pH, 40 minus pH. So this is equal to 40 minus pOH. We have got this minus 3. So pOH is equal to 11. Next problem, second problem we are going to see. Calculate the H plus ion concentration of solution whose pOH is 8.6. We have given pOH which is equal to 8.6, and we have asked to calculate H plus ion concentration. So how we can calculate? From pOH we can calculate OH minus ion concentration. Therefore how we can calculate H plus? We know the relation pH plus pOH is equal to 40, because to calculate H plus ion concentration we must know the pH, because these two have the relation. pH is related to H plus ion concentration. So if you know pH, then you can calculate H plus ion concentration. So we first calculate pH. 14 minus pOH, that means 14 minus 8.6, which is equal to 5.4. So therefore pH is equal to, now we can calculate H plus ion concentration as pH is equal to minus log of H plus. So 5.4, which is equal to minus log of H plus. Now we know, and now we want the H plus ion concentration, so we can take anti-log of 5.4 is equal to minus anti-log of log of H plus ion concentration. So log get cancelled. Therefore this negative sign I am taking on this side. Anti-log of 5.4 is equal to, this get cancelled, so only H plus ion concentration. Taking this negative sign inside, so anti-log of minus 5.4 is equal to H plus ion concentration. Now to find out the anti-log, now as this negative sign, this is also negative and the term after decimal is also negative, but we cannot see the anti-log of negative terms, so we want this term positive. So how it is done? By making plus 1 and minus 1. So this is equal to anti-log of minus 6. Now this is plus 0.6, which is equal to H plus ion concentration. So anti-log of minus 6.0 minus 6.6 is equal to H plus ion concentration. Now we can see the antilog of positive term, that is 0.6, and it becomes the antilog of 0.6 is 3.98. This minus 6 will be in the power of 10, so 10 to the power minus 6. This is what is the H plus ion concentration, mole per liter. This is how the H plus ion concentration can be calculated. Now the next problem we will see. The next problem is, now this problem is related to the degree of ionization. Degree of ionization of 0.1 molar monobasic weak acid is 0.130. Now in this problem we have given the degree of ionization, which is shown by alpha, of a monobasic weak acid. Monobasic weak acid in the sense the acid which can give only one H plus, that is called as monobasic acid, and weak acid, the acid like acetic acid which cannot dissociate completely. Those acids are called as the weak acids. So such monobasic weak acid is having the degree of dissociation of 0.130. Calculate the pH of solution. We have asked to calculate pH and pKa of monobasic weak acid. To calculate pKa, the relation of pKa and Ka is minus log of Ka is nothing but pK. That means to calculate pKa, we need to know the value of Ka. And to calculate the pH, what is the formula for pH? pH is equal to minus log of H plus. That means to calculate pH, we must know the concentration of H plus. Both of these values they are not given in the problem. We just given alpha. Therefore, to calculate this pH, we know that, for example, monobasic weak acid, we will take one example. Acetic acid. This acetic acid, this dissociates as acetate ion and 1H plus ion. Right? Therefore, the concentrations of these undissociated form and dissociated form at equilibrium are, if we consider that concentration of the acid is C and the degree of dissociation of it is alpha, that means the fractions of these two ions formed are alpha and alpha, and their concentration can be calculated by multiplying them with a C. So these are the equilibrium concentrations of these ions, and the concentration of the unionized form is, the fraction which is remaining at equilibrium is 1 minus alpha, and to calculate concentration we can just multiply it by C. We want to calculate the concentration of H plus, so we will use the formula C alpha. Now we have given the concentration of the monobasic weak acid, and the concentration in the problem is 0.1 molar, because in problem the degree of ionization of 0.1 molar monobasic weak acid, that means the concentration is 0.1. We know alpha, so we can calculate H plus ion concentration. C is 0.1 and alpha is 0.130. That means H plus ion concentration is 0.0130 moles per liter. This is the concentration of H plus. Now we know H plus ion concentration. So from H plus ion concentration we can calculate now the pH. So minus log of H plus. So this is equal to minus log of H plus is 0.0130, and this is equal to 1.886. This is what is the, here actually the log comes to be minus 2 point something, and due to the negative sign the minus 2 will become plus 2, and the mantissa which is remaining, that you will have to minus from the remaining term. That means what if this is minus. Here the characteristic will be bar 2 point. Sum of the log of this term will be there. So this will become plus 2 and the remaining term you will multiply with the negative sign. So whatever the minus into this term will be, and this comes out to be 1.886. So this is what is the pH. Now we want to calculate pKa, but for pKa we must know Ka. Now what is the formula for Ka? It is 3 alpha square divided by 1 minus alpha. This is what is the formula to calculate Ka. So let's substitute the values. 0.1 into 0.130 divided by 1 minus 0.130. So this is equal to 0.1 into 0.0169 divided by 0.87. So this is equal to 0.00194. This is the value of Ka. Now therefore pKa is equal to minus log of Ka. This is equal to minus log of 0.00194. Therefore pKa is equal to 2.7. Here also the log of this will be bar 3 point something the log will be. When you multiply it with a minus sign inside, so this will characteristic will become plus and the mantissa will become minus. So 3 minus whatever the log is, that you will have to subtract from plus 3 and the answer is 2.71. Now the next problem. The pH of 0.005 molar ammonium hydroxide is 9.95. Ammonium hydroxide, its pH is given 9.95 and its concentration given is 0.005 molar. Calculate its ionization constant. Now ammonium hydroxide is a big base. That means we have asked to calculate the ionization constant, that means Kb and pKb. This we have asked to calculate. Now again ammonium hydroxide we have given. Ammonium hydroxide we know that this dissociates weakly as, this is a weak base, so this will dissociate as NH4 plus and OH minus ion. Now if I consider that this is the concentration, C is the concentration of ammonium hydroxide initially. Initial this will be 0. At equilibrium, what their concentrations will be? If alpha is the degree of dissociation of ammonium hydroxide, so at equilibrium, the fraction of this that will remain undissociated, that will be 1 minus alpha. Alpha is the fraction which is dissociated. So how much will remain of the ammonium hydroxide? 1 minus alpha, and this will be formed, these fractions of these two ions will be alpha and alpha. Their concentrations will be, just multiply their fractions into concentration. So these are the concentration of ionized and unionized form at the equilibrium. Now what we have given is to calculate Kb, what I need is alpha, the value of alpha I need, right? Because Kb is equal to C alpha square divided by 1 minus alpha. We know alpha, but we don't know the concentration. What concentration we need? The concentration of, here we have given the concentration. We need to calculate this alpha. Now, therefore, how we can calculate alpha therefore? OH minus concentration is equal to C alpha. Right? We have given pH, so we can calculate pOH. How we can calculate pOH? pH plus pOH is 40. Therefore, what is pOH? pOH is equal to 14 minus pH, that is 9.95. So it is 4.05. This is what is the pH. Now from pOH I can calculate the concentration of OH minus side concentration. So pOH is equal to minus log of OH minus side concentration. pOH is 4.05 minus log of OH minus concentration, and now we can therefore say anti-log of minus is equal to concentration of OH minus. Now to solve this, what we have to do first is we have to make this positive, minus a positive, so we can say the anti-log. We cannot see the anti-log of negative term, so this we want positive. So how it can make positive? By +1 and -1. Subtract 1 from this minus term and add 1 to this remaining term. Now, therefore, anti-log of minus 5 plus 0.95 is equal to OH minus ion concentration. That means you have to see anti-log of minus 5.95. Now see the anti-log of 0.95, and that is, the anti-log is 8.91, and this will be in the power -5. So the concentration of the OH minus ion is 8.91 into 10 to the power -5. Now you know the concentration of OH minus. Now you can calculate the alpha. To calculate alpha, what we can do is, you know OH minus concentration, so alpha is equal to OH minus and concentration divided by concentration. So 8.91 into 10 to the power -5 divided by concentration 0.05. So alpha comes out to be 0.0139. Now you can calculate Kb. Kb is equal to C alpha square divided by 1 minus alpha. So this is equal to 0.005 into alpha 0.0139 square divided by 1 minus 0.0139, and this comes out to be Kb is equal to 9.79 into 10 to the power -7. This is the value of Kb. So we have found Kb. See, we had given only the pH and C concentration, and we have asked to calculate ionization constant and pKb. Therefore, what we first do, as this is a base, therefore NH4OH we have given. In the problem, NH4OH, this is given and its pH is given. To calculate Kb, this is the formula to calculate Kb. Concentration is given in the problem, but we don't know the value of alpha. To calculate alpha, we had take the concentration of OH minus, which is equal to C into alpha. Now OH minus concentration can be calculated from the value of pOH, but we know pH. So what we do? We first calculate pOH, and from pOH we calculate the concentration of OH minus ion, and from the concentration of OH minus ion we calculate alpha, that is the degree of ionization of the big base. Once we found alpha, we can calculate ionization constant for the base, and once we found the value of Kb, that is the ionization constant for ammonium hydroxide, we can calculate pKb. pKb is equal to minus log of Kb. So this is minus log of 9.95 9.95 79 into 10 to the power minus 7. So we can calculate the answer here. So this is how we can calculate pKb. Now the next problem is a buffer solution containing 0.25 molar acetic acid and 0.5 molar sodium acetate. Calculate the pH of buffer solution if ionization constant of acetic acid at room temperature is 1.82 into 10 to the power minus 5. Now this problem is depending on Henderson-Hasselbalch equation for the buffer solutions, and we had seen this formula. See, in the formula we have given 0.25 molar acetic acid and 0.5 molar sodium acetate. These are mixed to form the buffer. That means this buffer is formed, or this buffer is of the type, the buffer of weak acid strong base. It's a strong base. Weak acid and it's a strong base. So this is what is the buffer. Now we have asked to calculate pH of the buffer, and the ionization constant of the acid is given 1.82 into 10 to the power minus 5. This is what is the different terms we have given in the formula. So this is the given data. Now, so we want to calculate pH. Now, for the pH of the buffer of the weak acid with its mixed with its strong base, the formula is pH is equal to pKa plus log of concentration of the salt divided by the concentration of the acid. Now see, in the formula, this is what is the salt which is used to make the buffer. We know the concentration of the salt as well as we know the concentration of the acid. We just don't know the term is pKa. We know Ka, therefore we can calculate pKa as pKa is equal to minus log of Ka. So this is equal to minus log of 1.82 into 10 to the power minus 5. So this is equal to, here to calculate the log, what we can do is minus log of 1.82 plus minus log of 10 to the power minus 5. So this is equal to, whatever the log you will get is here, the log will be minus, and minus log of 10 to the power 5, minus 5 power come into the multiplication. So minus minus will become plus 5, and the log of 10 is 1. So here the log of all this term is plus 5, and whatever the term here will come, that will become negative. So here it is 4.7. This is the pKa of the acetic acid. Now pH we will calculate. pH is equal to pKa. What we have got? pKa 4.74 plus log of acid concentration divided by, salt concentration divided by acid. So 0.5 divided by 0.25. So this is equal to 4.74 plus log of, now 0.5 divided by 0.25 is log 2, and log 2 is 0.3010. So pH of this buffer is equal to 5.041. So this is what is the pH of the buffer solution. So this is an acidic buffer which is formed by mixing the weak acid and its salt with strong base. So rest of the problem we will see in the next lecture.